Om Sri Sai Ram. My humble salutations to my beloved Bhagwan, respected elders and my dear students. Hearty welcome to Hermite differential equations, Hermite polynomials. Now today we are going to learn another question, that is Rodrigues formula for Hermite polynomials. The Rodrigues formula for Hn of x is given by minus 1 whole power n into e power x square into nth derivative of the function e power minus x square. Now here you can see the generating function of the Hermite polynomial is given by e power 2tx minus t square is equal to summation t power n by n factor into hn of x, n running from 0 to infinity. Now giving values for n equal to 0, 1, 2 etc. we get h naught of x t by 1 factor into h1 of x plus t square by 2 factor into h2 of x plus etc. t power n by n factor in times hn of x plus t power n plus 1 by n plus 1 factorial times hn plus 1 of x and so on. Now we know that the derivative of t with respect to t becomes equal to 1. Similarly, the second derivative of t with respect to t square becomes 0. Suppose if we are having t power 5, then the derivative of t power 5 with respect to t is equal to 5 t power 4, and the second derivative becomes, that is 5 into 4, 20 times t cube, and the third derivative of t power 5 becomes 20 into 3, that is 60 times t square, and fourth derivative of t power 5 becomes 120t, and similarly fifth derivative of t power 5 becomes 120, and sixth derivative of t power 5 becomes 0. So hence differentiating both sides using this concept in the above equation. Now differentiating both sides with respect to t n times and then put t equal to 0. So the left hand side becomes nth derivative with respect to t d power n by dt power n operating on e power 2tx minus t square, that becomes equal to, that is h naught of x becomes 0, and then h1 t times h1x 0 and so on. Only the nth term t power n by n times becomes n factorial. So n factorial by n factorial times hn of x. And then the further terms, actually we get n plus 1 factorial by into hn of into t power we get, but putting t equal to 0, then n plus 1th term also becomes 0. Here in the nth term, n factor by n factor, that becomes 1 hn of x, that is hn of x. So the hn of x can be written as nth derivative d power n by dt power n e power 2tx minus t square. Here I am going to add x square on both sides in the power. So e power x square plus 2tx minus t square by minus x square. So that is equal to, now e power x square is independent of t, so e power x square I am going to bring it outside. Then in the power we are going to get only 3 terms, namely plus 2tx minus t square minus x square. Even that also I am going to make it as a perfect square by taking minus common. So that becomes e power minus of x minus t whole square. So finally hn of x becomes e power x square times nth derivative with respect to t e power minus of x minus t whole square. Now put x minus t equal to u, then derivative with respect to t, partial derivative with respect to t is nothing but dou by dou u times dou u by dou t. We can write dou by dou t can be written as dou by dou u times dou u by dou t. But dou u by dou t, what is u? U is equal to x minus t. So dou u by dou t becomes what? Minus 1. So minus 1 into dou by dou u. So hn of x is nothing but minus 1 power n into e power minus x square into nth derivative d power n by dx power n e power minus u square. So that can also be rewritten as, because it is only simply the variable u, so we can as well, you can write hn of x equal to minus 1 power n into e power x square into nth derivative d power n by dx power n operating on e power minus x square. So finally this is the Rodrigues formula. Thank you for watching this video.